Algebra 2, last lesson of this school year. Lesson 12-5, working with samples. So a sample, you gather information from a population. So a sample size, let's say you had 5,000 people and you selected 500 of them. 500 is a sample. The sample proportion is x over n. So like this one here, I had 1,035 voters. 526 were in favor of candidate A. So you take, this is going to be your x, that's how many are in favor of, and this is your total amount. So to find your sample proportion, you take 526 over 1,035. Okay, and then you can just find that, 526 divided by 1,035, so that would be 0.51, or 51% were in favor of candidate A. That's simple. Random sample, each member is likely to be chosen. So if we're sitting in class and you are a sample of the whole entire school, and I just go through and count down by 5, so every 5th person, that's a random sample, because every single person has an equal chance of being chosen. Okay, so that would be a random sample. Okay, so come over here. Margin of error. Every time you have something, you have a chance for error when you're dealing with your percentages. So you have a margin of error. The margin of error in this case is going to be plus or minus 1 over the square root of n. So 1 over the square root of the total number of people. So let's say I had 300 people. My margin of error would be plus or minus 1 over the square root of 300. Okay, so 1 over square root of 300 is 0.06. Okay, so that would be my margin of error, plus or minus. So now, finding sample size for margin of error. So they're telling me that 10% is my sample size, or plus or minus 10. So I'm going to plug in this, and I'm going to change that decimal over, equals 1 over the square root of n. Cross multiply. Square root of n times 0.10 equals 1. I'm going to ignore the plus or minus because that's going to eliminate. Okay, so then I've got the square root of n equals 1 over 0.10. So 1 divided by 0.10. And then to get rid of that root, square it. So I get root n equals 10, n equals 100. So that would be my sample size. Easy math. Last thing, actually second to last thing, so I'm going to go over some bias here in a second. 236 people out of 1,121 people tested positive for COVID-19. I want to find the sample proportion, so I got to find my x over n, so A. My x over n, I would take 236 over 1121. Okay, so 236 divided by 1121 gives me 0.21%. So 21, I'm just going to go ahead and move my decimal over, 21%. So there is my proportion. Margin of error, so I need to find my margin of error. Well, that would be 1 over the square root of n. So B plus or minus 1 over the square root of the 1121. So 1 divided by the square root of 1121. Plus or minus 0.03. Or plus or minus 3%. To find your true population proportion, this is where we're using the plus or minus. So this is where the plus or minus comes into play. So for C, you've got your percentage, which is 21%. Well, I'm going to take 21% minus 3, so I'm going to get 18%, to 21% plus 3, 24%. Okay, done. Now, what I've told my probability and stats, because the question's always been, why is this disease much more dangerous than the common flu? If those were my stats, this would be extremely dangerous. Because the reason why it would be extremely dangerous, if you have anything greater than 0.05, so anything greater than 5%, it's of concern. And so if you look at the whole entire population and how many people have been affected, so you take how many people have been affected, tested positive, and you divide that over the total number of population in the United States, if it is greater than 0.05, we've got a real issue, and that's why this was considered such a big pandemic. And it just increased rapidly, and we don't have a vaccine for it, so that was another reason. One other thing on this lesson you're going to be asked for is bias. Is there any bias to some of these? They're going to give you like a paragraph, and you got to tell me if there's any bias. So if you're biased against something, that means you're either for or like extremely for or extremely against something. So, or you're at the wrong place at the wrong time. So if I were to ask people if they liked, let's say, McDonald's French fries, but I was standing in a Burger King asking people, that's biased because I'm standing in a different restaurant. If you are just sampling people, asking people survey questions in a regular old grocery store, that can be considered biased because you're not using a true population. You're only using a population of people at that grocery store. So you got to look at that when you're dealing with bias. They'll ask you, a supermarket, this is number 4, a supermarket wants to find the proportion of shoppers who used reduced price coupons. A manager interviews every shopper entering the greeting card aisle. Why would you just use the greeting card aisle? That's biased. You need to use every aspect in there. Probably best thing is to wait at the door and survey them as they're walking in. So make sure you're reading those thoroughly and just identify what's biased about them. So that's today's stuff. An unbelievably an easy lesson. This is our last lesson. Woohoo! I know you guys are so disappointed. So there it is, lesson 12.5, samples.